So hello guys, in this video we will try to cover the improper integrals. So in this video basically I will try to cover the theory part of improper integrals, and in the next video I will try to cover around 5 to 7 examples so that you can relate with the examples so that you can solve on your own. So first of all, what is integration? Basically, let's say you can see here this is called integration. Now basically when first case, when a comma b not equals to minus infinity and positive infinity or plus infinity, or function fx is bounded in the region, or you can say interval a comma b, then it is called a proper integral. Hopefully you can understand what is the definition of a proper integral. Now basically, what is improper integral? If one of the case will not be valid or both of them will not be valid, in that case we will say that the integration is not a proper integration or proper integral, it is an improper integral. Now let's talk about it briefly. So first of all, we will talk about the type 1 improper integral. So remember it, just type 1 is basically where we will deal with the first case, like maybe the lower limit is minus infinity or the upper limit is infinity, or you can say positive infinity. And there will be another type which is called type 2, where we will deal with this case where the fx, the function, is not bounded in the region or interval, or basically you can say function is not integrable. So, and there will be multiple types, like we will see some types will be mix up of both of them, one or two. So however, let's start with the basics. First of all, what is type 1? Type 1 integration, I mean improper integration, is like minus infinity to b fx dx, a to infinity fx dx, or minus infinity to infinity fx dx. You will see three subtypes or sub integrals. I mean basically, like you can say this is the first one, this is the second one, this is the third one. So how will we solve? Right? Basically, how will we approach it? So your first approach is like, let's say I is equals to, for this, minus infinity to b fx dx. So we have to do something like that. Let's take b tends to minus infinity. This is b, this is small b. I mean, however you can understand. This is for this case. What we will do this for this case? We will take limit. Let's say integration is equals to basically limit a tends to infinity. As I have taken b as minus infinity, so I have to take another variable, or you can say another limit. However, so this is basically small a, this is capital A, this is fx dx. Now what about this case? This is important case. Now we are talking about minus infinity to plus infinity fx dx. So we have to break the limit into some points, like minus infinity to something, say c, and c to infinity. Point to be noted, fc should be exist, okay, fc should be exist. What I am writing, I don't know. Exit, oh no, damn. Well, my spelling is very bad, however just ignore it. So basically it should be exist. Now basically it should be bounded on that point, or you can say Like it is not like fc is negative infinity or undefined or something like that. This should not happen. Hopefully you can understand. Now yes, there will be fx dx plus fx dx. Now you can see this is nothing but the subtype 1 and this is nothing but the subtype 2. Basically subtype 1 plus subtype 2. So for solving this kind of integral we will use this approach. In the next video I will provide some examples so that you can understand with that. For at that moment just remember it. Now let's talk about the type 2 where the function is not bounded in the region. So basically you can see, let's say function dx, this is 0, this is let's say a, this is let's say b, and f of a is equals to infinity or minus infinity or basically undefined. Basically you can't define it. Let's say in that case this is called the type 2. Maybe you will see that in like there will be two cases, like f of b, this is for first subtype, this is for second subtype. F of b will be infinity or minus infinity or as I have said to you undefined. So for these cases we will do something like that. Limit epsilon tends to 0, basically 0 positive. Let's say we are talking about subtype a, so a minus a plus epsilon b fx dx. Why we are using this plus symbol and what is epsilon actually? So basically you are using plus symbol. Let's say the function is defined from this point to this point, a to b. Now we can't take a point at that region or at that region. You have to take a point at that region, that anything between a and b we have to take a point. So epsilon is nothing but it is tends to 0 positive, which is basically greater than 0, and epsilon basically less than b minus a. Now for making the region inside between a and b we have to take epsilon and we have to add epsilon with a so that we can shift the point from a to this. Let's say this is epsilon, this distance is epsilon, hopefully you can understand, and this point is a plus epsilon. Okay, hopefully you can understand. Now let's talk about subtype 2 where b, or you can say the upper limit, is this. I mean the function is not bounded at the upper limit. So basically if we are talking about f is equals to infinity or minus infinity, wait a moment, now it is visible, or undefined. Now basically in that case we will again use a epsilon. Now as I had already used epsilon, so I will use delta, and delta tends to 0 positive. Okay, hopefully you can understand again. Now integration, the lower limit is a, it is fixed, but the upper limit is changed, and this. Now we will explain, I will explain why this is why there is a minus symbol, because again we are talking about a to b. So if we are talking about a to b, you have to take a region or you have to take a point between a to b. If we are doing b plus delta, then we will take this region, or if we are taking a plus delta, then we will take this region. But in that case the upper limit is not bound, I mean the function is not bounded at the upper limit specifically. Basically we can't find the value of the function at the upper limit, so we have to take a point inside the region. Inside the region means between a to b we have to take the point, so it is less than b, so b minus delta, sorry not epsilon, this is delta. This is the process. Now there will be some kind of question which you will be going to face, where we will see something like that, where f of a and f of b both equals to infinity, minus infinity, or undefined. In that case let's say a to b fx dx. Hopefully you can understand what I mean. In that case, what we will do, we will take another point between a and b. Maybe it is the midpoint, doesn't matter, again doesn't matter. Just f of c should not be equals to infinity or undefined or minus infinity, blah blah blah. However, this is, let's say, c, so you have to break the limit a to c, then c to b. Now you can see a to c fx dx plus uh, this is fx dx. Okay, fine. Now basically in that case the function is not bounded at point a, but it is bounded at c. So basically we have to take limit epsilon tends to 0 positive a plus epsilon c fx dx plus limit. In that case the function is not bounded at the point b, or basically at the upper limit, right? So in that case epsilon, or you can say not epsilon, we are taking delta because we had already taken epsilon, so we will take delta. Now basically you can see this is b, wait a moment, b minus epsilon, again I'm doing a mistake, b minus delta c fx dx. Now you can see this is basically, again we can see here, this is basically the summation of both the cases, both the subtypes of type 2. So hopefully you can understand the type 1 and type 2. Now we will talk about some specific tests so that you can relate with the questions in the next video. But in that video we will talk about some specific test. I will tell you the name, then I will explain. First of all, comparison test, limit test and mu test, which is too much important. Mu test is too much important. You should know mu test, and you have to write something during solving any question. Like let's say examiner will give you a question and examiner is telling you that or say let's say telling you that prove that the given integral is an improper integral. Then how will you prove? Then you have to understand from the type 1 and type 2, or both the mix up of type 1 and type 2. Let's talk about another example, which is not example, basically another theory where we will deal with the mix up of type 1 and type 2. Basically we will see infinity or minus infinity at the limits, and basically I'm doing something, wait a moment, you can see this is infinity, this is a, and this is fx dx. Let's say f of a is equals to infinity or minus infinity or undefined, let us assume. So basically fx is not bounded at point a, which is the lower limit, and you can see an infinity here. So basically it is the summation of type 1 and type 2, type 1 plus type 2. In that case, how will we deal with that question? Again we have to take a point c between a to infinity. Okay, a to infinity we have to take a point so that you can relate with that. We have to break the limit like that, a to c, c to infinity. You can see this is basically nothing but fx dx. This is basically nothing but the type 2 first subtype, where the lower limit is doing something badmoshi. Jokes apart. Jokes apart, ignore. And in that case you can see the upper limit is infinity, so it is the type 1 and type 1 subtype 1, where the upper limit is infinity and upper limit is basically creating a trouble. So this is the process. Now let's talk about 3 tests which all are too much important for solving any kind of question, for testing any kind of integral, that it is improper or not. So let's move on to the next topic, which is comparison test. So basically the statement is, if let's say if fx be a non-negative integrable function where x greater than equals to a. Well, I have to write it, otherwise you can't understand. Let me write. Let's say fx is there, which is a function which is non-negative integrable function. Non-negative, which is non-negative integrable function. Okay, integrable means we can do the integration. However, and where x, what is x? X is a variable, and it is greater than equals to a. What does it mean? It is basically meaning, meaning that like it is a lower limit. Like you can say x will be greater than equals to a, which is basically x will be a, or the value of x will be more than a. So x is the, x minimum is basically a. You can say something like that. So if we are doing if we are symbolizing it using an integration, then we will see something like that. Where what is b? B is the upper limit and b greater than a definitely for all cases. Now let's say b is tending to infinity. Let's say b is tending to infinity. Okay, just assume. So in that case, we can say the integration is looking like that, fx dx. Now the comparison test is saying to us basically nothing but this integration. Let's say this is I, it will converge. I will converge. And what is the meaning of converge? Convergence means I has a fixed value, or it will converges. What I'm saying, sorry, it will converge in a particular value. Like if I'm saying, let's say there's a series dot dot dot. The value of this series is basically maybe 0, maybe 1, depending on the series. Let's assume we are taking n digits or n terms. In that case, if n is let's say, sorry for a moment, this is 1 minus 1 then plus 1. If n is odd, then this is 1, the summation is 1. If n is even, the summation is 0. So it is not convergent. Okay, it is not convergence. It is not converges basically, specifically. However, it is not the part of this question, this theory. So if and only if I will, what I'm saying, sorry, you can say if and only if I will converges. Oh, again mistake. I will converge if, let's say, there is another function which is gx, which is basically nothing but the neighborhood of fx. Neighborhood means, let's say we are talking about 1 by x cube, 1 by 1 plus x cube. This is fx. So what will be the neighborhood function of fx? Let's say this is gx. We are denoting the neighborhood function as gx. So gx is nothing but this. Hopefully you can understand. It depends on the question, and we have to understand the question so that you can find out what is gx. Now the comparison test is saying to us if gx will converge, I'm writing, wait a moment, sometimes I make mistakes, sorry for that. Let's say gx, if gx will converge, then fx will converge also. And this is the first. There will be a second statement, which is if gx diverges, then fx also diverges. Hopefully we can't understand this theory. Without example, it is next to impossible to understand this theory, but just try to understand. I'm repeating the theory, which is basically there is a function fx which is non-negative function, and the lower limit is, let's say, a, and this is the integration, and we can integrate fx with respect to dx from the limit which is a to b greater than a, and b tends to infinity. This is the integration, you can see. Then I will converge when when gx, which is the neighborhood function, which is the neighborhood, let's say this is fx, basically this is x, this is x, this is x-axis, let's say this is a, this is fa, and this point is gx, or you can say ga. Neighborhood function, hopefully you can understand. Neighborhood function means this is fx, so this is gx, side by side, you can see. So the condition is, if gx will converge, fx will also converge. If gx will diverges, fx also diverges. Hopefully you can understand. Without example, it is next to impossible to understand this theory. So let's move on to the next theory, which is basically mu test, where we will deal with a very hard theory. So now you can see this is the mu test, and I have given a single star to this theory because this is one of the important theory for understanding the improper integrals, for finding the convergency or divergency of a, let's say, integral, I mean improper integral. So in that case we will deal with the type 1, like a to infinity or b to minus infinity, like b to minus, I mean minus infinity to b, however, fx dx, and f of a not equals to, let's say, infinity, minus infinity, or undefined. Basically I want to say fx is bounded at the region, but as there is an infinity, so this is an improper integral. So now what is mu test? Mu test is something like that. Fx, I mean sorry, the integration, let's say I integration will converges absolutely. Be careful the word, be careful about the word absolutely convergence. I will talk about absolute convergence after comparison, sorry, limit test. I will talk about absolute convergence, which is also an important topic of this theory. So basically I will converge absolutely if limit, be careful about this formula, x to the power mu, limit x tends to infinity, x to the power mu fx is equals to lambda, where lambda is not equals to plus minus infinity. So hopefully it is not visible properly, now it is visible. And where the mu should be greater than 1, doesn't matter whatever the value is mu, I mean whatever the value of mu, we are talking about only greater than 1. So how will we choose the value of mu? It depends. It depends on the question. Definitely it depends on the question. Now basically when I will not converge, if the limit, I mean basically the lambda will be equal to plus minus infinity, or you can also say that basically mu less than equals to 1 in that case. But we have to show both of them, like lambda is equals to plus minus infinity, what I am writing, plus minus infinity at this also. We have to show both of them so that we can prove that I is not a diverging. Basically we can't integrate or something like that. So this is the mu test, and without example you can't understand mu test because you can't understand the value of mu. It depends on the question. So I'm just giving you the formula to do the mu test. So let's move on to the next theory, which is called limit test, which is also important, but mu test is too much important. In the limit test we'll talk about gx also, where gx is nothing but the neighborhood function of fx. Let's say this is the graph, let's say this is the graph of fx, and this is x. Basically this is a graph. Now we are talking about a particular point a, we are talking about a particular point let's say b. Now basically in that case b is tending to infinity, however we are talking about b, we are not taking this point at that moment. Just understand, this is, let's say, fx, specifically fa, this is, let's say, fb. Now let's say the graph of gx is something that you can see, this is the point of b, however and this is the point of A. So basically this is G of A, and you can see this point is G of B. So basically Gx is the neighborhood function which is looking like almost similar to the fx. Let's say we are talking about 1 by 1 plus x cube and 1 by x cube. Both will be almost same. Both will be almost same. However, uh, like we can give another example, which is, let's say we are talking about 1 by ex plus 1. So in that case, uh, the gx will be treated as 1 by e to the power x. Hopefully you can understand. We will talk about some examples after this video, I mean in the next video, so that you can understand more and more. Basically you can solve in your own. So basically what is limit test is saying to us? Limit test is saying to us basically like limit x tends to infinity fx by gx is lambda, where lambda is not equals to 0. Be careful about that. Be careful about that. Lambda is not equals to 0. Now now what is the concept? Like basically fx, where fx is, let's say this is the graph. Let's say this is the graph of fx and this is the graph of, let's say, gx. You can see both are touching, both are like tending to the infinity, right? Both are tending to the infinity. Now at x equals to infinity, the ratio will be constant. What does it mean? It is basically saying to us, let's say this is fx by gx, right? So we can say this is basically fx by x and gx by x. We can say this is basically the slope 1. Let's say this is mf, this is mf, and this is slope 2, which is treated as, let's say, mg. Hopefully it is visible to you. So the slope, the ratio of the slopes of both the curves will be constant. This is the theory, and you can prove it using a simple mathematical tool which is called mod, basically specifically modulus. But we are not going towards the proof because it is too much complicated. I'm not saying that proof is too much complicated, because it is not necessary to you to understand the proof, because it will not come to your exam, and like this is basically the limit test. This is for all about limit test, and let's move on to another very important thing, or very important concept, which is basically absolute convergence and absolute divergence. Sorry, not there will be no kind of absolute divergence. There will be only one thing, which is absolute convergence. Now let's talk about absolute convergence. Now basically, for understanding the absolute convergence, we have to understand one thing, which is called the Cauchy Cartesian. uh, Sorry for a moment, this is not Cauchy Cartesian. sorry. Basically first we need to know a theory which is called the uh, Cauchy's criterion or something like that. Please google it. I don't know the exact name, but uh, this was proved by Cauchy. So this is Cauchy Cartesian or Cauchy criterion. I am not sure about that, but the theorem is basically like, let's say we are talking about a to infinity, and the integration is fx dx I. Okay, now basically it is basically like the Cauchy's Cartesian or criterion. However, what is this? I don't know. This is saying to us x prime and x double prime. This is the limits. This is the limit, and this is the, I mean, this is the lower limit and this is the upper limit. Fx dx, and the mod of this integration is less than epsilon, and epsilon, you know, it is tending to 0 positive, basically tending to 0. Now this condition should be valid, and there will be another capital X. And what is X? X is nothing but a positive number. Understanding this theory is too much complicated, And if you want to understand, you need to do some questions, otherwise you can't understand. This is the Cauchy's criterion now, or Cauchy's Cartesian. However, now what is the absolute convergence? Like, this integral should be less than equals to x double prime and x prime fx dx, where x double prime is greater than x prime and greater than capital X. Again, capital X is a positive number, nothing more than that. Again, understanding this is too much hard without any question. Now, basically, what is absolute convergence? Absolute convergence is like, if we are saying, basically, let's say this is the integration and we are taking the mod of this integration, infinity a fx dx. If this is, this integration, let's say this is I dash, it will converge, then this integration will be called absolute converges integral. Okay, and if the mod of fx dx a to infinity, it will converge, then it is not absolute. Hopefully you can understand. Now in that case, you can see this two will not be equal, right? And basically we are using the Cauchy's criterion, and we are transforming this to this, and we are transforming this to this. Hopefully you can understand. Both are same and the limits are different. Just we are using the Cauchy's criterion to convert this to this and this to this. It is very easy to understand, but like without example you can't understand. So in the next video I will try to provide some examples and try to solve some examples where we will solve this question also, like sin x by x, let's say 0 to infinity dx. Without Feynman's trick we can't solve this integral. However, even we can't solve this integral, we can't solve this integral without using the Feynman's trick specifically. Basically differentiation under integration. But in improper integral we will prove that this will converge or this will diverge. Well, will it converge or diverge? I will not exposing that in this video. In the next video we will discuss. Basically we can't integrate, and you can see this is basically the summation of type 1 and type 2. Specifically type 1 subtype 1 and type 2 subtype 1, where we will deal with this and this. We have to break this into two parts or something like that we have to do, but we will do this question using the Cauchy's criterion and absolute convergence. And this question is a little bit hard and you have to understand it deeply, so that you can feel the question. In the next video we will discuss it, and that's all for this video. Thank you for watching my videos, and what should I say, I don't know. If you want to subscribe, then subscribe. If you want to comment, then comment. If you want to like, then like. And if you will subscribe, then also click on the bell or something, whatever it is, doesn't matter, bell icon or something like that, so that you can get the updates. And nothing more than that. Thank you, goodbye, take care, or blah 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 blah. Goodbye, thank you.